I'm pleased to introduce our keynote speaker, Scott Hunter. You can tell he's here to talk about Python and Go. He dressed for the occasion. But it turns out that even though he's talking about those topics, he's the VP of product for the Azure Developer Experience team. So all the cool tooling for Azure in Visual Studio and VS Code, right?
And command line.
And the command line. This is all, and it, you know, for those that were in my workshop yesterday, you know, it's pretty cool stuff, right? I don't think I'm going to read.
You don't need to. That's
stuff,
too much
right?
stuff there. That's way too much stuff.
Right. So, I mean, you've been with the community forever, and we really appreciate you. And take it away.
It's been a long time. Yeah. So, thank you, Rocky. To add more, my career at Microsoft is kind of funny because I started off in .NET, and I joined the ASP.NET team back in 2007. So, I'm on the 15th year of my 5-year Microsoft journey. Then in 2010, when Scott Guthrie moved to Azure, we all moved to Azure with him and brought ASP.NET there. And that is where, you know, anybody here building on .NET 5 or .NET 6 or trying the previews of .NET 7, all that work kind of came out of the Azure group. We were in Azure, and while we were in Azure, we saw, hey, the world's changing, Linux is everywhere, open source is everywhere, and we had to go reinvent .NET. And so we kind of reinvented .NET while we were in Azure, and then we all came back to Visual Studio DevDiv around 2016, and that's when we shipped the first version of .NET Core. Interestingly enough, all those services that we worked on, all those tools we built in Azure came back to the developer division last year. And so now we put it all back together again. We have the services, we have the frameworks, we have the tooling that's kind of all together. And so that's what I do today, is I work on the .NET stuff, I work on the tools for Azure, I work on some of the services in Azure. And today, I want to talk about a few things, but we already showed the session slide. Question for people in the room. I can start with the crazy stuff or start with the normal stuff. Who wants crazy stuff? Crazy stuff. Okay, so let's just skip through this stuff. Yep, that was some good stuff. Okay, I'm not going to skip through all that stuff. There's a couple things that you probably haven't seen because we haven't made a big deal about it yet. One of the things that, you know, in .NET, obviously we saw years and years ago, we created something called Web API, which was the .NET way of building APIs. We've been investing in that space forever. And there's a bunch of weird stuff there, or not weird stuff, there's a bunch of stuff we've been doing there that really helps a bunch of other things. So, for example, you know, I'm a pro developer, but, you know, I hear this word like Power Apps is for low code or no code. I've not found anybody other than a pro developer that can write a Power App. Just saying. But Power Apps do bring a bunch of benefits. I mean, you write the application, the app runs on the web, it runs on a mobile, it's got automatic authentication to AD. And so we actually built a bunch of tech in .NET 5 for Web API that enables you to pass an identity from a Power App to your .NET Web API code. And so that means when you call the API from Power Apps, the API, you'll get the token inside of .NET, and you can then make your own calls to the Teams APIs or M365 or SharePoint or whatever on behalf of the user that was running the Power App. And we did that when we first started. That required like 6 pages of garbage to be added to your ASP.NET application, and we knocked that down to a couple lines of code in .NET 5. Another thing we worked on is, you know, probably aware we added something called Open API to .NET. Which is the description of your APIs, so it can be used by tools. We have tools in VS that'll actually generate you proxies automatically with that stuff. But now we can actually give you the ability to publish your applications right to API management, and it can pick all that stuff up as well. So, and so there's a bunch of stuff there that kind of all comes together. And I'm going to ask people, because I hate this word, who in this room knows what Fusion development is? Nobody. Perfect. So if you're bored, Google Fusion development. That really is what this low-code thing is. But we put a bunch of things together. We've got all that web API support I mentioned before around Open API, the tooling we have, the being able to publish out to API management, because API management is the way that you get a third-party API into Power Apps. You go put it in API management, and there's a bridge from API management to that. The next thing is, so you see here, APIs, API management, Power Apps, it all goes together. This is the coolest feature we've added to Visual Studio. It's coming to VS Code as well, and this is called port tunneling. And so that if anybody's ever used a tool called Ngrok, the idea here is if you're debugging APIs, sometimes it's very difficult because the API is running on your local host. My phone is not on the network that my PC is on right now. And so if I want to call the API from my phone, I can't because there's no way to get it into localhost. And so with port tunneling, it's a feature we added in VS. It's in there now. You have to turn it on. It's a preview feature, and I can launch VS and show you how to do this. You can now take your web APIs in .NET and give them a public URL, which means suddenly mobile development's a lot easier, Power Platform development's a lot easier, anything that needs a public API. In our case, what we're going to do is Brady Gaster on the team is going to build a Power App, but his API is an API management. API management's a public URL. It can't see localhost on the machine. So we're going to take our API, we're going to blast it in with port tunneling and make it available so API management or anything else could do it. And it really requires just like 1 or 2 lines of code change to enable this feature. It's super cool. We've been trying to do this for 5 years, and we finally got it out the door. It's built on the same tech that we do live share in VS Code and Visual Studio. Okay, so, and it was in public preview. Let me just do this real quick, because if not, I'll forget to show you. So the way you'll turn this, you'll get this feature is you're going to go to Tools, Options, and Preview Features, and there you see, there it is right there. Port tunneling for web applications. So here is, I've been burned enough times doing these things. Anytime we're doing any Azure stuff, in fact, at one of these conferences where the network went down and nothing worked, and so we have a video here from Brady Gaster, and he's going to show you how to use this port tunneling feature to debug an API running on a public endpoint in API management.
Here I have my Power Apps environment. What I'm going to do is I'm going to dev copy. This is the app I'm working on. We'll just see when I go ahead and run it. If it's making the call out to an API.
Can I get more volume?
Right-click deploy this API.
I can do it.
And within Visual Studio, I've got the ability to include an APIM deployment. So I've ingested my API in APIM, and so far it seems like things have been working, but I got to report that there's an error on it. So I want to try to figure out what's wrong. And so this delete feature seems to be working, so that will actually delete it. Now I've got 6 pending, whereas a minute ago I had 7. And now I want to go to a different one that I want to approve, and oh, yep. Looks like I got some kind of an error message. So I'm going to need to figure out what's going on here, see if it's just that issue or if it's all of them. I'll click this one. Yep, looks like I've got some sort of a bug in my API. So I'm going to need to actually debug the API with this Power App, which can be a little bit tricky. I'll bring over Visual Studio here. Here's my actual feed endpoints extensions, which is really all the different feed endpoints. And the one that I'm going to have to debug is this one, this put, because that's where we're actually updating the user-submitted feeds. I'm going to put a breakpoint right here and hit F5 and just kind of see if I can debug it. And it's probably a familiar problem whenever you've got to debug an API that's getting hit from an external, client, is that whenever you hit F5 on it, you're going to be debugging, on localhost. So it's kind of hard to actually hit it from, something like a Power App or something running in the cloud. The good thing is we've enabled a new feature, port tunneling in Visual Studio, and I'll go ahead and create a couple of additional settings in my launch settings file here. One is create tunnel. I'll set that to true. And
just pause there. Just 2 things there. You just give it a create tunnel true and give it a tunnel name, and you're ready to go.
And the second one is to give it a tunnel name. And now when I hit F5, when I debug my API, rather than debugging it on localhost, we're actually going to open up a public tunnel back to my localhost machine and give myself a public DNS that I could actually drop in any kind of a cloud provider, any client, and hit it. So you can see there's my fully qualified domain.
There you go. There you can see we've now got a public URI, .NET Popcast, blah, 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 set up and ready to go. So that's showing you by adding those two features. Now I can call this from the public.
Name. That tunnel that I asked for, subtunnels.api.visualstudio.com. Now I'm using API management, in Azure to deal with my custom connectors and Power Apps. So what I'm going to do is I'm going to paste this URL, which is now that tunnel, back to myself into this API management instance. This is actually.
So API management is now going to call that public tunnel we just created, so it can actually now call the local machine.
API management instance that I just deployed to from Visual Studio, which we're using as a custom connector. And you can see when I hit the get user submitted feeds, it's working. Just to kind of make sure it's working, I'm going to put a breakpoint right here in that method, and I'll go back over again and hit send. And yep, looks like we are now directing traffic from that APIM front door back to my machine through the new feature of Visual Studio called port tunneling. So now what I'm going to do is open up my Power Apps client here one more time. We'll go back into that dev copy of the app that I'm working on. And now you'll see got 6 running here. And I want to go ahead and try and approve one of these with my breakpoint set inside of that put method. And look, there you go. And I can see, oh, that's what's wrong. So I'm passing 2 parameters to that find method. It looks like I'm passing ID and cancellation token. Like maybe I copied and pasted those parameters and didn't think about it. I'm going to go ahead and back that out, get rid of that cancellation token, and just pass ID. And I'm just going to hit the debugger again. It's definitely going to stop my Power App from running, but that's okay. I'm the only one hitting it. It's my dev copy. So now what I'll do is I'll go back over to my Power App again. This is my browser opening up, but we're running in that tunnel. And since I'm running in the tunnel and the APIM is hitting my machine, I can hit this and we'll tunnel right back to my machine. You can see there's that ID that I just sent. I indeed found that feed, and now it looks like things are working. So we're good to go. It looks like it's going to remove that feed from that context, and now we're off and running. So now I can go down and try another one here. Make sure things are good. Give that one a continue.
And so you can see that that port tunneling makes it where you can do amazing stuff, get your APIs out to the public on your local machine, enable a bunch of other cool things. Next thing is something we don't talk enough about in .NET. I think we hear containers and cloud native, and I like to give the .NET team a bunch of crap all the time. I'm like, what have you done for cloud native? I mean, I'll challenge anybody. Google cloud native in .NET. You will find Microsoft listed 18th down the list. And so one of the things you're going to see us really focus on moving forward is how do we enable developers to build cloud native apps. And what cloud native actually means in many cases, it means apps that were developed for the cloud. And it also means apps that were designed so they could scale. We've all built a legacy app where the SQL database is the biggest thing that blocks you, and you're kind of stuck there. And so about a year ago, we took a project called Orleans. Orleans is not a new project at all. It's an old project. It's been around for a long time. In fact, it goes all the way back to the first Halo game. And Orleans, I'll use all the terms that you should never use when you talk about tech. Actor framework is what it is, but we'll never use that term ever again. That's put away. What Orleans lets you do is when you create an object, you can share that object across more than one machine of your application. So if I'm going to scale my application horizontally and say, oh, when the load gets this high, I'm going to create more instances of the app in the cloud. Well, what we've all done in this room, I know we've all done it, is what we do is we go out to our relational database and we grab a profile out of the database and we shove it into either memory inside of the application, maybe that session state, or maybe you shove it into a Redis cache. And then you have to remember every time you change that object, I got to go update it in the database, and I have to go update the cache so it reflects across all your applications. And so this is going to be a piece of tech you're going to see us really simplify and clean up. What if in the future you could just say, hey, I want this, I'm going to grab this profile object from EF Core, and when I grab it from EF Core, I want to just basically make it an Orleans object, which means it's now accessible across my entire set of VMs, and anybody that asks for it will just get a memory version of it in most cases. If somebody changes it, we'll actually change the memory version of it and change the one on disk for you automatically. And I'm using SQL as an example. That could be Cosmos, it could be whatever. And so the idea here is literally this slide. Brady and I are in the process of cleaning this up right now. But the main point here is it's going to use a term called a grain. We're getting away from that. We support POCO, which is just plain old objects. You'll be able to do in Orleans 4. And so once I create a grain, that grain exists across every implementation that I'm running. So if I'm running 4 versions of this thing on 4 VMs, every one of those 4 VMs has access to this grain, and they have access to it in a fast way. And so we think this is part of how you would scale a .NET app up. And so it says, the goal of making distributed computing possible. It's actually the secret sauce behind many things inside of Microsoft. There's a thing called Microsoft Mesh. There's things like Xbox Live. Once again, that's that profile thing. When you see a profile on Xbox Live, that's an Orleans object. And the reason we can scale Xbox Live to tens of hundreds of millions of people is because of this kind of tech. And so it's awesome for cloud native scaled applications. And as I said, there's cool stuff coming in 4.0. We're now going to start shipping Orleans as part of .NET. So in November with .NET 7, there'll be Orleans 4. And you're going to see us have more and more tight integrations and make it easier to use. Now, before I do the demo of this one, I want to go back and because I jumped too far ahead. This was the app that we used at .NET Conf last November. It's called the podcast app. And all the demos that I'm showing you, the port tunneling demo, the Orleans demo, are all inside of this repo. So the repo is right here. If you want to take a picture of the screen, or I'll actually have the slides sitting around afterwards. Great place to go grab. We actually make sure this works on the latest .NETs all the time. So it runs on the latest .NET 6s. It runs on the latest .NET 7s. And you can try the port tunneling feature there. You'll be able to try the Orleans thing there as well. So I jumped too far ahead. Now, what we're going to do is one of the features in the podcast app we used at .NET Conf last year was ability for I can hang out with a bunch of my friends and listen to a podcast together. And so that's a great example of where an Orleans object makes a lot of sense. We're going to create a room, and that room should exist on any machine that we scale the app up to. And so Brady's going to show you how he added Orleans support to the podcast app.
So here you'll see the Listen Together part of the .NET Together podcast. What we're going to do is I'm going to go into one of my favorite shows. I'm going to click on the Listen Together icon. I'm going to enter in my name and hit Open Room. Now what it's going to do is it's going to give me a room code. I'm going to copy that. Another user can take it and go to the Together mode, paste in the code. But before we hit the Join Room button, what we're going to show you is that we've added Orleans to this. Because it's really great for building these distributed apps, and it's really great for doing like backends behind the
So this is pretty cool. We give you a dashboard with Orleans. So you actually add a line of code to your .NET application. And from that, we'll, just like we could give you that API thing for Open API, we'll give you a dashboard for Orleans, and you can actually see all of the objects existing in the world and scaling across all the machines.
Application where we want to control things in the state. So in this case, I want to control the state of a room. You'll see here that that grain just fired off the join room method twice, one for the user who created it, one for the second. You'll see as I scroll through the track here, you'll see the update player state method's going to get updated as well. Go down here and I'll do the same thing. And there's that update player state method firing off because that grain is actually executing. All right, now I'll click leave room. See that leave room method's going to fire. I'll go over here to discover, and before I do, go back here to grains. I'll go to a different show. This time I'm going to go ahead and click join the room, enter in my name. And you'll see this time when I hit open room, now we're going to have 2 grains because I've got 2.
So we're showing you, we have 2 objects now being cached and run around the world by Orleans for us as he's running code.
Different rooms. When I hit leave the room, you'll see one goes away because there's nobody in the room. We don't need the grain anymore. And then I actually leave the room again, and there you go. That's a great example of how Orleans grains can persist state in your app. Here's what that looks like. In my program CS, I wrote some custom service wire up in middleware, add Orleans and map Orleans dashboard, which we've added in the Orleans extensions file.
So you can see there's the map. That's the dashboard. We just added up here. And he's got a few other hookups here as well, where he's going to hook up the state, where we store the objects when they go, when they've been around
See
too
what I'm
long.
going to do is I'm going to look and get my connection string. for Azure Storage. I'm going to give my Orleans cluster a name and a service name. I'm going to wire up storage as my backing store for the state and configure my endpoints. And then I'm going to turn on the optional dashboard just because I want to be able to see everything going on. That's the dashboard you saw running here in the background. And that's going to answer at the WAC dashboard endpoint. And here's what my grain looks like. I inherit from grain and the iRoom grain interface. See.
So he's using an older version where he has to actually make the object actually implement from iGrain. In New Orleans 4.0 that's going to be out this fall, you no longer have to do that. Just a regular object, any object you can say, make it an Orleans object.
You've got join room and leave room, and set room and update player state. And those really just make calls to the domain objects in the back. We really already used them before. Like I said, I didn't have to change the hub code because we had these request handlers, and all I did was I went in and changed our calls from instead of going directly to the our fronted database. Now I'm actually making a call to get that grain from the grain factory and then calling the grain methods on that. What's cool is I got this running in my container environment. So you can see here I've got my listen together hub. I want to use VS to go ahead and attach to that process and kind of set a breakpoint. And now what I can do is I can just attach to it and set my managed.NET Core for Unix as the thing I want to attach to. And now when I actually run my code, I can step through it. And that gives me the opportunity to kind of see what my code's going to look like when it's executing inside of that container or inside of a Kubernetes environment. I can actually kind of test it running directly inside the container environment and kind of get a better idea for what's going to happen in production. See, there's my incoming username and my connection ID. So I can actually figure out what's going on. So what we've done is we've added Orleans to the podcast sample because we think it's a great feature for distributed dev and one of the features of Orleans. And this is the contrib dashboard. So we can kind of get a background view of what's going on in that Orleans cluster. Thanks a lot.
So that's Orleans, and we'll skip through a few more of these. Now let's talk about a couple of .NET 7 things, and I'm going to talk beyond .NET 7. This is actually some of the tech that I work on today that is super important, I think, for all of us is containers. I think it's very obvious that as you look at compute moving forward, Kubernetes is everywhere. We have AKS in Azure, and people like Kubernetes because Kubernetes is vendor neutral, it's cloud neutral. If your app runs in Kubernetes, you can run it anywhere. I'll jump back in a second and talk about container apps. It's another way that you can run your apps on Kubernetes without having to manage the Kubernetes. But what we're seeing is the unit of deployment to the cloud is becoming containers. And so one of the challenges that we have with containers is, I struggle every time I set a machine up, a Windows machine up, the first thing I have to do is go turn on Hyper-V, then I have to install WSL, then I have to install Docker Desktop. That's at least 2 reboots. And Docker Desktop now wants me to pay them, so it's not free. And so, wow, if I have to do all that work to make a container that I can publish to Azure or anywhere else, that just feels too hard. And so we are actually in the process of prototyping a new feature that will likely ship in the after .NET 7, where you can just take any of your apps, any of your cloud apps, any of your ASP.NET applications. You don't even have to add a Docker file to them. Why do you have to write a Docker file? I want to publish my app. It's going to run in a container in the cloud. And so this is a prototype that we wrote. And I will challenge somebody. There's an Easter egg in the prototype, and I'll ask after you see the demo if anybody sees the Easter egg. But this is building containers in .NET without having Docker for desktop, without having Hyper-V, without even having WSL running on the device. Basically, any developer can be a container developer, and here we go. This is Tim Hewer on the .NET tooling team that's showing a cool prototype.
And this is a demonstration of a proof of concept to help you get to Azure container-related services and registries as fast and friction-free as possible using Visual Studio. First, let me show you the current state today. I have a ASP.NET Web API here, and I want to get it to Azure Container Apps, Azure Container Registry, or App Service with containers. In Visual Studio, you would do that using publish, and so I'm going ahead and say I want to go to get to Azure, choose I want to get this to my container registry. We have great Azure tooling to allow you to create Azure resources and provision new ones. I happen to have an existing one here, which I'm going to go ahead and select. Awesome. Visual Studio has helped me configure that. Everything looks good. I'm going to click Publish. And looks like I cannot actually get to Azure Container Registry because it's asking me that you need Docker.
Yep. Now I need to install more stuff. Yuck.
I happen to have an existing one here, which I'm awesome. Visual Studio's helped me configure that. Everything looks good. I'm going to click Publish. And looks like I cannot actually get to Azure Container Registry because it's asking me that you need Docker. That's right. I've heard of this Docker thing. I've been told I need to add it to my application. So great. Visual Studio says, hey, great, awesome. Add Docker support. Sure, I want Linux. Awesome, I have this now new file that maybe I'm not familiar with as a concept, as a developer, because I don't usually work in containers. I'm just trying to get my app to containers. But that's fine, everything looks good. I'm now going to click Publish. Still can't do it, and the real reason is because it's telling me exactly here. You need this thing called Docker Desktop. And when I go to that URL, it's going to take me here and saying, you need this, all these tools, I need this thing, how do I download it? It's going to ask me to reboot a couple times. Not a great process. So fast forward, let me go ahead and delete this, and let me show you what we're trying to do to make that process as smooth as possible. And that process actually added a couple artifacts to our concept, so let me go ahead and clean those up and remove those.
So not only removing the publish profile, we're also deleting all the Docker files and all the other files that we added as part of this. We want to make this as seamless as possible.
Profiles and show you that we don't need any of these in order to get to Azure Container Services. So I'm going to go through the same process again and make one change and show you how simple it's going to be hopefully in the future. Please keep in mind this is a proof of concept, so there are some rough edges, but let's go ahead and do that flow again. So again, I want Azure Container Registry, and I want to select my existing registry. So click Finish. Same aspect here. Now, just as an implementation detail, we hope that you would not have to do this, or we'll make an option for it. But now I want to say I want to use implicit container support, and I'm going to just set that to true. And again, we will smooth this over in the tooling experience, but inevitably that's the option that I'm going to choose. If you remember, I clicked Publish before, and
if you want to watch for the Easter egg, watch the output as we build the container.
Added a couple warnings and had to do it a couple extra steps just to get my container as fast as possible to Azure. Now I'm just going to click Publish, and you can see we're already processing. So we've eliminated a couple steps, making it as fast as possible to get there. And the .NET SDK now is taking the responsibility of pushing this. And very quickly, I got my app to Azure Container Registry, which now I can use in an Azure Container App or app service extremely quickly. We can go to the registry here, and you can see that I had nothing there before. Let's click Refresh. And here's the latest that we just pushed right here with all the information and all the different layering that goes along within containers. So we're hopefully removing some steps for you to understand. Now, because this is a part of the .NET SDK, you would be able to also do this from the CLI. Now, I'm using the publish profile capability in .NET Publish in this proof of concept to be able to just say, hey, .NET Publish, and use all this information, which contains all the same information that we have in this publish profile, defining the Azure registry I want to get to and some authentication type information. Now I can also use this in my CI builds, and so having a great Visual Studio experience, but also a SDK level CLI experience to help you do the same thing as quickly as possible using your CLI and in your CI tools without additional SDKs or tools. And you can see I've gone and done that very quickly, and if we go back and refresh, we can see the latest here, and we can see that's the latest update was just 1 minute later there. So thanks for watching the video, and we hope to get your feedback on this experience.
So questions, anybody see the Easter egg? It'd be very hard to see unless you actually run these commands by yourselves. So the joke was that prototype was actually using Java to actually make the container. So that's why Tim is like, this is a preview prototype. Just imagine, it's like, let's install Java when we install .NET. But the idea here is we hope that we get you to a place where, as I said, we're going to have container tools that are so good, you don't even have to think that you're using containers. It just becomes a unit of deployment, and you're good to go. This next one is something that's actually in the .NET 7 previews that are out there today. Once again, you've probably all seen in .NET 6, we did a lot of work. We called it I hate the term that we use. We called it minimal work. But really what it was is we were looking at, what does a entry-level Python API look like? What does an entry-level Node.js API look like? And how does .NET compare? And that's where you find, and I can jump back and talk a little to this. This is one of my favorite features in .NET 6. Being able to do this, where you can create an API in 3 lines of code, required features in C# 9 and C# 10. First off, there was the tech we added where you could just not have a program, not have a main, not have a class, just write some code. That happened in C# 9. And then in C# 10, obviously, we have global usings, which allow you to take all the usings away. I've been doing .NET for 20 years. I cannot believe it took us till 2022 to not have using system at the top of every file. Then we got namespaces that don't require indentions. You can just do a semicolon, because how many people do multiple namespaces in the same file? I don't think I ever have. And we added, somebody said once. We added records in C# 9, which lets you write an entire class in a single line of code. We added that struct support for that in C# 10. This is the best one is the Lambda one, which is there used to be so much typecasting required to use a Lambda. Imagine being a brand new Python developer or JavaScript developer. Somebody in the room goes, hey, you should try .NET. And the first thing you see is func string event. Yuck. Getting rid of all of that enables us, this Lambda here where it says map get, / to hello world, that would have required a func before. I saw the version that required the func, and we all barfed on it and said we can't do that. But that leads us back to, once again, the idea here is, every version of .NET, we go look at what we've got and we say, how hard is it to do something? Doing authentication in .NET authorization and authentication in .NET is not trivial. I'm sure there was workshops here probably this week talking about that. And so we've done a lot of work in .NET 7 to really clean that up. And this was an example of what it would look like to add some authentication and authorization to an application in .NET 6. That's a lot of code. And builder.services.add authentication, jot-bear defaults.authentication scheme, blah, blah, blah. Our goal, we're trying to make .NET more accessible to everybody. And so in .NET 7, something like that looks more like this. Builder.authentication.add JWT-bear. Of course, you can still get to the crazy one that has all the overloads if you need that. But in many cases, we find that you don't need all those overloads. And then you can see all I had to do here was then just put a require authorization and a require claim onto my API, and I'm good to go. And so this is something you'll see us continue to do in .NET is find areas that look hard and try to go make them better. And this is just the tip of the iceberg. .NET 8 will have a lot more stuff in this space. Because I'll just kind of say, I think authorization and authentication are becoming too big for frameworks to try to build themselves. We're Microsoft. We have this thing called Azure AAD, Azure Active Directory. There's companies like Auth0. There's a variety of companies that provide this. Like people ask us all the time, are you going to add FIDO support to .NET? Are you going to add this support? There's so many options now, I don't think we can keep up. And so I think in .NET 8, you're going to see us really focus on how do we enable you to use these cloud auth providers much easier than you can today. Now we can talk about crazy stuff. WebAssembly is something that we kind of took we made it as an experiment a couple of years ago. It started off kind of as a Blazor thing, but many of us thought that WebAssembly could go way beyond just being able to run a Blazor application inside the browser. There are plenty of teams inside of Microsoft right now that are experimenting with actually using WebAssembly on the edge or on the server. Because today we compile our applications. Imagine you compile your application to be an ARM app, or to be an x64 app, or to be an x86 app. With WebAssembly, it's kind of an intermediary thing where you can build a WebAssembly app and you don't really care what the architecture is. It could be a mainframe, it could be a Raspberry Pi, it could be my desktop. And so there's two things I want to show. Number one is some folks have got Sql Lite ported, so Sql Lite can run in WebAssembly. And this means you can actually run a database in your browser in a Blazor application with this. And so, so now you can basically run EF Core in a Blazor app and have your own database on the machine. So let's take a look at this. And I want to say this works in .NET 6. So you can do this in .NET 6. It works better in .NET 7, but it does work in .NET 6.
Let's talk about a new package that's available today that may help you with your Blazor WebAssembly apps. Here I've got a Blazor WebAssembly app. You can see these are the only dependencies I have. I've added a to-do class for a classic to-do list. You can see in my code I basically am creating 3 new to-dos, adding them to the list, setting that to an array. Then I have
So basically, he's going to start off building a to-do app, doing all the to-do in memory. So without using a database at all, which means he's going to lose state.
a little feature to mark them as done. Pretty straightforward, but let's go ahead and run that. And what you'll see is it's created some new to-dos. I can click done on 2 of those. I've moved to the counter, I come back, I've got a new set of to-dos, which is what we would expect. So let's see if we can do something about that. So I'm going to stop my application. I'm going to go into NuGet Package Manager, include pre-release. I'm going to bring in Entity Framework for SQL Lite, and we're going to use the core package so that we can specify our own version of the underlying SQL Lite. So we'll go ahead and install that. And then for the SQL Lite package, and we want this eSQLite 3 bundle here. So we'll go ahead and notice in the instructions
And I've done this demo before, eSQLite 3, no idea what the heck that even means.
here says call SQLite PCL batteries init. So I'm going to install that. And then I'm going to follow the directions and call batteries init. Let's go ahead and create a DB context class. Call it to-do context. This is going to be a DB context. We're going to create 1 table for the to-dos. And then I'm going to override the configuring to use SQLite. And we'll give it a name, data source equals to-dos SQLite 3. Okay, so now we have a DB context. We want to use our services to make it available. So I'm going to do builder, services, add DB context factory, to do context. And that's all it should take to wire it up. Now let's enhance our index page. What we'll do is we'll inject that DB context factory. And then we're going to change our code a little bit. Right here, what I'll do is I'll get rid of this list. And I'm going to use the factory to create a context. And I'm going to make sure that the database has been created for me. I'm kind of bypassing migrations to keep this demo simple. And then here, we'll add this to the context. After the loop, we'll save it. And then down here, we'll get this from the context. Context to-dos to array. And then the last thing we'll do is on our markDone method, we'll say using var context equals factory, create context, var update equals context to-dos single, we'll mark it done, and we'll save changes. And we'll go ahead and mark the to-do done too for the UI. Okay, so that's all it is. Now this is, notice there's no ASP.NET Core application. This is a complete standalone Blazor WebAssembly. We'll run this. Now notice in the build, it's adding native assets. It's using mscripten to compile the SQLite module into WASM. Now notice our to-dos have IDs because they've been saved to the database. I'm going to mark this one done, and I'm going to mark this one done. We'll go to counter, we'll come back, Well, it remembered that they were done, and it's added some new ones. And so we keep accumulating the list because we now have.
And so that's WebAssembly running SQL Lite in the browser. And that works with .NET 6 as well. The next one, and I'll make sure that, I know we're going to send the decks around. I'll make sure there's a slide I add to the deck that actually has links to where you can try these things as well. So the EF Core with SQL Lite you can run today. This is that next step, which is, WebAssembly can be more than just being in the browser. And so what we're going to do is we're going to run .NET applications. We're going to compile your entire .NET app to WebAssembly. We're going to run a console app in the browser. And then we're going to actually run an ASP.NET application as a WebAssembly as well, showing that we can run this stuff anywhere. And we're going to see this show up in a lot of places because imagine I'm running a proxy server today. The problem with the proxy server is I have to write the code in whatever language the proxy server was written in. I don't want to write my proxy rules in C. This is going to enable TAC to actually say you write your rules in Java or .NET or whatnot. And so this is, and WASI is the standard for running WebAssembly on the server. So let's watch this.
Let's look at an exciting new experiment for .NET. This is a .NET project. It's a console application. You can see .NET 7. And the program itself, very straightforward. Gives the current time and tells you which OS architecture it's running on. Let's go ahead and run this. And as expected, what we get is the time and that we're running on OS architecture x64. Now let's make a simple change. I'm going to go into NuGet Package Manager, and I've got this custom feed that has an SDK for WASM. We'll go ahead and install that. And now we're going to run the same program again with no change. And what you see is I'm running on OS architecture.
So now we're reporting that we've actually compiled the thing to WASM, and it's now running as WebAssembly. And so now the code can run anywhere.
WASM. If we look at our files, I'm going to open in File Explorer. You can see if we go into bin debug .NET 7, we actually have this hello world on WASI.wasm. Now this is a completely standalone file. In fact, there's a web-based version of WebAssembly, webassembly.sh, that I can upload this file to. So right now it has a list of built-in commands. We're going to do upload, and we'll navigate to our demo, and we'll grab that WASM file. And now you can see there's that new command, and it runs. I'm running on OS architecture WASM.
So he's actually just in a browser. He just uploaded the file to the browser. He's running the app in the browser, but that's only so cool.
That's not exciting enough. This is not just for trivial situations, because what I have here that I'm going to set as a startup project is a WASI version of ASP.NET Core running completely on WASI. Let's go ahead and run that. As you can see, the WASM trace logger has launched. This is actually run with a WASM runner. It's not run directly off the .NET runtime. And what's important to note about this is that because it's standalone, it can be bundled up and run anywhere that WASM supported. This is a actual Razor page. There's also a minimal API that I have a plugin that allows me to navigate the JSON results for. So this is ASP.NET Core running entirely on WebAssembly.
So that's pretty cool stuff. I'll talk one more thing about .NET 7 real quick, and then I'll try to tell you what's real and what's not real about all the stuff that I showed. Something else is there's still plenty of obviously existing ASP.NET .NET Framework applications out there. And so one of our other goals in .NET 7 is to find a way to help people migrate these applications forward to the newer bits. And so this is a feature called in-app modernization. And the idea is we're going to run your regular web form application, and we're going to run a .NET 7 application right next to it. And the way it works is if the .NET 7 application processes the URI, we'll let .NET 7 process the URI. If it doesn't, it falls back to the .NET Framework application. And so the idea here is to let you actually move your application forward page by page. You don't have to go try to port the entire application to .NET 7. You start a new .NET 7 project, and you replace piece by piece the stuff that's inside of an existing .NET Framework web-style application. Obviously, we need to make sure that you can actually share state across these two things because they're running as separate apps in some ways. And so we're doing work where we can actually share state across these things. The time that we wrote this slide, it was limited to a few simple types, but we plan to add more types to it as well. Because that's one of our core messages is, we think that now with .NET 6 and .NET 7, now's the time to take your older applications if you're still modifying them and move them forward because the tech is just so much better than that older tech. And so that's kind of what this slide was saying. Our wave is app modernization, better cloud native, the Orleans kind of stuff. And then, of course, Maui. I haven't talked about Maui a lot today because there's a whole .NET Conf thing that I crashed this morning that's talking about the Maui release that just happened a few weeks ago. Oh, yeah, and I forgot to show you, it's like, I didn't show you the slide. Yeah, I do think this is kind of cool. As you talk to customers, one of the things that's amazing about being on the .NET team and working on .NET at Microsoft is lots of .NET is used at Microsoft. And it's kind of crazy that we don't really talk to the public enough about how we use .NET at Microsoft. And in this case, if you actually hit if you're running an application in App Service, that's our web hosting tech in Azure, it's going through .NET Core or .NET 6. Every request is. Anytime that a request is made to the Azure Active Directory Gateway, it's going through .NET. Anytime anything hits Dynamics 365, it goes through .NET. Many of these things are actually written in .NET themselves. Bing.com is an example of that as well. But we wrote this proxy that we shipped with .NET 6. It's not part of .NET, but it's something we shipped. We built it because many of these teams in Azure, they had a challenging need. They needed to run on both Windows and they needed to run on Linux. And you can't use Nginx as your proxy because there's only a Linux version of it. There's not really a Windows version of it. And so we wrote this proxy to solve that problem for these customers. But it's a great example of how we use our tech internally at scale that just makes mind-boggling scale. You can see here, over 100 billion requests a month, 7 petabytes of data transferred. That is showing you that we're running .NET at scale levels inside of Microsoft that is unheard of, and which means if you're using .NET, you're getting a product that's got great scalability because we're running it and pushing it as hard as we can. I'm about out of time. This is kind of a cool one. We shipped, at the build time frame, we shipped Visual Studio 2022 for Mac. And if you're expecting it to have all the features of Visual Studio for Windows, no, it's not going to have that. But I think the coolest thing about it is we have that application now runs on .NET 6. So we ported the entire IDE, which used to run on Mono, to run on .NET 6, and we did that because we wanted the application to be able to support the new M1 Macs. And so because .NET 6 supports M1, you get that for free. And so you also, the app is much faster than the previous versions because it's been getting all those perf benefits that we've done in the newer .NETs. And so it's kind of an exciting thing to me to say that we're starting to see the tools switch over from older frameworks to the newer stuff that were happening. And I hope we see Visual Studio for Windows do more as well. I do think it's also important to always talk about how healthy the tech is. So, .NET's at about 5.6 million developers today. It's a 20-year-old framework. We're adding about 1 million a year. So I assume if you're here next year in VS Live, we'll be talking about 6.6 million or more. And it's the number one most loved framework for 4 years in a row now, 19, 20, 21, 22 in the Stack Overflow survey. And the coolest one, which I wish you were here all in October of last year, the Cloud Native Computing Foundation does a survey where they're just looking at pull requests, they're looking at issues, they're looking at all the stuff, comments that happen in repos. And .NET was number one in October of last year. We shipped in November, and that kind of was the end of that. and it slowed down again. It's now picked back up again. I don't know where, I haven't run it this week to see where we're at, but it's pretty cool to think of a tech we only open sourced in 2014 is that busy on GitHub. And then of course, can't say enough about every release since .NET Core 3. .NET Core 3 started the trend where we saw more people move on to the newer .NETs faster and faster. People aren't waiting for LTS. Even though 6 is an LTS, people are moving because the perf is so good. And so you can see we had over 1 million people that moved already to .NET 6. But the coolest one to me is the 21,000 community contributions by about 7,000 contributors. And I have no idea if any of you are in the room. This is just a collage of people that we scraped off some stuff. But thank you very much if you are or were one of these people. I appreciate it. It's been a fun journey for us. I will talk a little bit more about this. This is something we just shipped at the build time frame as well. And as I said before, Kubernetes is this ubiquitous thing, but Kubernetes requires you to, once again, just like we hated those Docker files, I don't want to write Helm charts and all this kind of stuff. I'm a developer. I just want to write my code and I want you to scale it. And so Azure Container Apps, which is now GA, it's a great way to build applications and not worry about Kubernetes, but it is running. We are running you on Kubernetes. And we're going to give you a mechanism to actually eject out of it into Kubernetes if you want as well. If you want to own the whole Kubernetes stamp, you can. And this thing's built on a ton of open source. Kubernetes, Kata is an open source project we built for scaling applications. Dapr is a great framework for doing microservice-y kind of things. It's open source. We built it as well. And we're using Envoy and other open source tech behind the scenes to do some of the routing inside of container apps. And I'm not doing the demo today, but we added full support for container apps into Visual Studio, into Visual Studio Code. You can publish all your ASP.NET style applications there, either with a direct publish, or we'll generate the CI/CD workflows for you with GitHub Actions, and we'll do Azure DevOps in the future. We're not going to leave Azure DevOps out. I hope you appreciated that we didn't just do the, hey, let me show you what's new in .NET 6, and we went and showed crazy stuff, some of the stuff that's actually going to ship in .NET 7, some of the stuff that'll ship in .NET 8. I think it's always, I love being able to get a chance to share with people some of the stuff that we're thinking about. And if you have any questions, please come up afterwards, find me. I'll be in the hallways. I'll be at the reception tonight. Happy to answer any questions about Azure, .NET, whatever. I said I've been doing this .NET thing forever. Thank you folks so much. And please send a survey and tell them that you like me so I can come back and talk about .NET 8 next year.